In this video, we're going to learn how to look at a data set or a table of values and apply a couple of little strategies to it to see whether these points, when plotted, would yield a linear relation or a quadratic relation, or at this point in our math careers, neither, because there are other relations to learn about, but that's beyond the scope of where we're going to take this lesson. So, the first test we have to do when we look at a data set is we need to look at the x values first, and we need to ask ourselves, do they skip by a regular increment? And you'll notice when you look at this data set, it goes from -2, -1, 0, 1, 2. It's skipping by ones. So if your x data set is skipping by a constant value, then you can continue on with your test. This test involves beginning with looking at something called first differences, or examining the y values. So what we want to do is, while this thing is skipping by a constant amount, what is happening to y? And as we work our way down, you can see that going from a value of 10 for the first point to a value of 6 is a decrease of 4. Similarly, going from 6 to a value of 2 is a decrease of 4. Going from 2 to -2 is also a decrease of 4, as is going from -2 to -6. So, these are called first differences. And the neat thing to note is that when the first differences of the y values are a constant value, if you were to graph this, you would end up getting a linear relationship. Or in other words, you would be able to connect all of the points with a straight line quite easily. Let's examine another data set. Here, again, let's begin by looking at the x column. First of all, is it going up by a regular increment or a consistent constant increment? And the answer is yes. It's going up by 2's, therefore we can continue examining the y values. Let's look at the y values and apply first differences. So you can either look at what's the trend going from here downward, or you could take the second point minus the first one. Okay, either way gives you the same result. So 0 minus -10, just to switch things up, would be the same as 0 plus 10, or an increase of 10. You can also think of this as, if the temperature outside were -10, and then later on the day it were 0, you would have gone up by 10 degrees. Similarly, what happens here? Well, 0 to 18 would be an increase of 18, or you can think of it as 18 minus 0 would also give you 18. Continuing the analysis, going from 18 to 44 is an increase of 26, or 44 minus 18 also yields us 26. And then the last difference between the y values gives us the result of plus 34. So we notice in examining the first differences that they are not going up by a constant increment. And what that means is that if you were to plot these, you could not connect them with a straight line. So let's continue on and let's try taking the differences of the differences. In other words, we're going to take the second differences of these y values and let's see what happens. When we do that, we notice that a jump from 10 to 18 is an increase of 8, or 18 minus 10 is 8. Going from 18 to 26 is also an increase of 8, and going from 26 to 34 is also an increase of 8. So our second differences go up by a constant amount, which means when you graph this, you will get a beautiful smooth curve known as a parabola, which is a type of quadratic relationship. All right, let's try this analysis one more time with one more data set. Again, let's check and make sure that the x's are going up by a constant increment, and you can see just by inspection that they are. They're increasing by 1 all the way down. And you want to make sure if they were out of order, like let's say this 417 point was inserted in here, it wouldn't mean that you still couldn't do the analysis. You could just move it down so that you have this pattern of increasing by 1 as you go down the x column. Let's see what happens when we analyze the y data this time. We notice that in going from this first point to the second point, there's an increase of 1, an increase of 2, an increase of 4, and an increase of 6. So these first differences are not constant, so it would not be linear when you were to plot it out. Could not connect those with a straight line. Let's see what happens if we apply second differences. We notice that there's an increase of 1, an increase of 2, and an increase of 2. And I just realized that I did a little math error. Let's go back. 9 plus 8 gives us 17, not 9 plus 6. Let me try that again. And we notice an increase of 4. So looking at these second differences, this would also not be a quadratic relationship between these data points. And as I mentioned at the beginning of the video, there are all kinds of relationships between x and y values. So far in your math careers, you've explored linear and you're about to learn about quadratic. So this is another type of relationship that you'll learn about later in your math careers. So at this point in the course, though, if I were to say to you, what type of relationship is this? You would simply say to me that it is neither linear nor quadratic, because neither the first differences nor the second differences go up by a constant amount, and you could just leave it at that. So there's your introduction to being able to tell the difference between linear relationships and quadratic relationships based on given data tables.